Hi, in this lesson we want to talk about laws of exponents. Now there are namely 7 laws that we're going to discuss in this video. The first law being the product rule or the product law. This is where we have the same base multiplying another term with a different power. So what this amounts to is that if the bases are the same, then we add the powers, giving us a to the power of m plus n. This is the product rule. Then we have the quotient law, or rather let me not label them. The quotient law states that a to the power of m over a to the power of n, given that they have the same base a, we can subtract the powers. So a to the power of m over a to the power of n will result in a to the power of m minus n. Then we have the third law, which is the power of a power rule. So given a to the power of m to the power of n, this results in a to the power of m times n. So if we have a power of a power, we multiply the two powers. But if we have two bases that are the same, we add the powers. One base, two powers, we multiply. The fourth law is the power of a product rule. So when we're taking the power of a product, the product can be a multiplied by b, and we raise this to the power of m. This will be a to the power of m multiplied by b to the power of m. The fifth law states the power of a quotient rule. So similar to the previous one, we have a, but now over b, not multiplied by b, to the power of m. This results in each individual getting its own power. So a to the power of m and b to the power of m. Then the sixth law is the zero exponent rule, which states that any number raised to the power of 0 will always give us 1. Then the last law states that a to the power of a negative exponent will be equal to 1 over that exponent. Now, these are the 7 main laws that we use when working with exponents. And again, these laws are used when we're trying to simplify expressions. I've already used some of them in my previous videos, and you may have encountered at least 7 out of these. So all of them in your studies as well. But just as a quick example and elaboration on some of these, starting with the 7th law, it is important for you to realize that every number that exists over 1. Therefore, should we have a number such as 3 to the power of negative 2, this is technically 3 to the power of negative 2 over 1. Then, when we want to convert this such that it has a positive power, we take this term and move it to the denominator, such that we have 1 on top and 3 to the power of positive 2 in our denominator. So it's quite important when you're simplifying expressions and maybe you have a to the power of m times b to the power of negative m multiplied by c to the power of d. Maybe let's actually assign numbers to this. Let's say that's 3, that's 4, and that's 5. Simple enough. It's important that if you want to write this in its most simplified form, which is usually in positive powers, we usually don't prefer to have negative powers. So what we do is we have 3 to the power of m multiplied by 5 to the power of d all over 4 to the power of minus m. And if you're wondering how this came about, the intermediate step would be 3 to the power of m multiplied by 1 over 4 to the power of positive m, and then 5 to the power of d. Then just multiplying the 3m and the 5d such that they're in the numerator of our fraction. So that's generally how we go about that law. And it's also worth noting that on the fourth law, this is only applicable when we have fully simplified everything within the bracket to one term. For example, we could have 5a plus 6b squared. Then we would need to first solve what's in the bracket and simplify it first before we assign the power. And that would look something like this. 5a plus 6b cannot be combined since they are not like terms. If you've forgotten what like terms are, refer to the first lesson. So what we do in this case is, since we cannot assign this 2 inside, because the law is for the power of a product. This is not a product, this is an addition. If it was 5a times 6b, then we could assign the 2 to each individual term underneath this bracket, like that. But since that is not the case, since we have a plus here, let us not confuse these two laws. What we have to do here is expand 5a plus 6b and another bracket 5a plus 6b. And that's how you would solve that problem.